Well, hello. Oh, sorry. I had to turn up the volume there because it wasn't loud enough. Volume. We're talking about volume here. Anyway, all right, volume. This is section 26, day 2. So 26.2. Ooh, I've got red right now. In your practice book, this is on page 263. Okay, page 263. All right. I'm gonna have to switch away from red. I don't know if I can do that the whole time. All right, front page, we're dealing with this problem at the very top. So this whole lesson, again, is dealing with comparing volumes of cones to cylinders and spheres. So they're all three different types of 3D shapes, and they all have a circle on them somewhere. So that's the thing that's in common. And reminder, excuse me, with a circle, the main dimension is the radius on a circle. And that's halfway across the circle. It goes from the center to any part on the circle itself. So we'll be using that. We're also going to be using height. Um, So on this first one, it says the cone and cylinder at the right have the same radius and the same height. Find and compare the volumes. Write the volumes in terms of pi. So they did that. They took the volume formulas. So area of the base times the height. That's what it is for a prism in general, and works for cylinders as well. And then for a cone, it's 1/3 of that. So we use the formulas. The base is a circle, so the area of a circle is pi r squared. And so 1/3 pi r squared, you got 1/3, you put in the 2 for the radius times the height. 2 squared is 4. 4 times 6, again, this is 4. 4 times 6 is 24. And then 1/3 times 24 is 8. So it's left in terms of pi. That's what it means. You have pi in your answer. So 8 pi, oh, didn't mean to do that. Should be a box on that, 8 pi. The volume of the cylinder, area of the base times the height. We got pi r squared times the height, so it's just the pi times 2 squared times 6. And the 2 squared is 4 times 6 gets you 24. So we have 24 cubic centimeters. So if we compare them, if we want to compare the two, if we're going to do cone to the cylinder, it would be the 8 pi, that's the cone, to the cylinder, which is 24 pi. And that's actually what's shown right here as well. And that ultimately reduces, so you can cancel out the pi on the top and the bottom, because if you have it on top and the bottom, it cancels out, just like 1 over 1, or 6 over 6 cancels out to be 1. And then the 8 and 24 can both be divided by 8 to simplify it all the way to 1 and 3 and 1/3. So the volume of the cone is 1/3 of the volume of the cylinder. So that's how we can show again that really it is 1/3 of a cylinder. So we're going to use that example with our first three questions here. Number 1, what does pi r squared in the example represent in the cylinder and the cone? Well, pi r squared is the area of a circle, and that's the base of both of these. They're both circles. So we're going to say the area of the base, which is a circle. And that should be area, not air, or r, sorry. All right, so it would be the area of the base, which is a circle. Now, number 2, if the cylinder has a volume of 75 cubic inches, what would the volume of a cone with the same base and height be? And explain. So the cylinder is the bigger one, and the cone is 1/3 of that. So if you want to find 1/3 of that, you can just take 75 times 1/3. Or that's the same as 75 divided by 3. Either way, you get 25 cubic inches. All right, and it's because we know it's going to be 1/3 of the size if it has the same height and if it has the same base. Okay, if everything's the same, it's just going to be 1/3 of it. And number 3, if the height of the cylinder in the example were 12 centimeters, how would the volumes compare? So if the height of the cylinder was 12 centimeters, that would change it a little bit. So the height in the cylinder is 12 centimeters. So let's just say it's twice as tall. My guess is it's going to be not 1/3, or not like the cone won't be 1/3. It'll be like 1/6. It'll be twice as small. So let's just check it though. So if I did for the cylinder, pi r squared times the height. So the radius is still, what did we say the radius was? Still 2. Pi times 2 squared. But now we're going to say the height of the cylinder is 12. So this is 4. 4 times 12 is 48. So we get 48 and then pi. So how does it compare if originally our cone was 8 pi, 48 pi. Now that cancels out and we can divide them both by 8 again. It actually works out nicely. It's going to be 1/6. So essentially we took that 3 and we multiplied it by 2 because it's twice the size of the thing. So this time the cone is 1/6 of the size, or the cylinder is actually 6 times bigger. Okay. All right, we're going to apply that on the backside. It's a little bit more challenging on the backside, but we're going to apply that. We're going to actually compare spheres with cylinders. So on this backside, we're really comparing the cylinders with a sphere. But we're going to talk a lot about cylinders again. So number 4, the sphere and cylinder at the right have the same radius. The equations to find the volume of the sphere and the cylinder are complete the equations to find the volumes of the sphere and the cylinder in terms of pi. So it's kind of broken down for us. We're going to do this in number 4. So to find the volume of a sphere, you do 4/3 pi r cubed. So that's what's different here. This one is definitely different than the other two. So we have 4/3 times pi, and the radius is 6. So 6 cubed. We can simplify 6 cubed. Get your handy dandy calculator. Remember, 6 cubed means 6 times 6 times 6. So 6 times 216. And now when you take that 216, we can multiply it by the 4/3, those two numbers, and we still leave the pi in the answer. Remember, leave the pi in the answer because it says in terms of pi. So 4/3 times 216 is what you want to do then to finish it off, which would be the same as taking 4 times 216 and then divide it by 3. That works as well. But for 288 pi cubic feet. I wish I had 288 pi's. That would be great. Man. Anyway, let's find the volume of the cylinder. So it's pi r squared times the height. The radius is 6, and the height is also 6 in this one. So pi times 6 squared times 6. I know 6 squared is 36, so really we're doing 36 times 6. And 36 times 6, oh, that's 216. So we have 216 with the pi cubic feet. So if we're comparing the two, let's go sphere to cylinder. So 288 pi compared to 216 pi. Just like before, the pi's cancel out. We got to reduce 288 over 216. And you can tell the sphere actually has more volume to it. That's what it's showing here, 288 pi versus 216 pi. Let's see if we can divide these by anything. And sometimes you got to play around with it. But if you notice the last number is an even number, we're not going to try to like divide it by 5. That's probably not going to work out. 5s have to go into with something with a 5 at the end. So looking for some even numbers. Let's try like, well, what's 216? Let's just divide it by like 4. So 54. I wonder if you do 288 divided by 54. Nope. Let's try 12. 12 is a good number. Let's go double. Let's just double it. Let's try 24. So 288 goes into 24. We get 12. I'm going to try 24. I think that'll work. 216 divided by 24. I got 9. Okay, so that's good. It's not, I think it can go farther. Sorry, 12 and 9. Yep, you can simplify them by dividing them both by 3 yet. and I get 4 over 3. So simplified, it's 4 over 3, and that's interesting because 4 over 3 is part of the formula in this one. So in this case, if you have the same radius, it's always going to be 4/3 the volume of the cylinder that's similar, which is really interesting. So the sphere is 4/3 times bigger, in this case 4/3 times bigger than the volume of the cylinder. All right, number 5 and 6 are questions that kind of are based off of that, and we're going to check something. So it says consider the cylinder in problem 4. So the cylinder we just did, we got 216 pi cubic feet. If you double the length of the radius, what do you think will happen to the volume? Double the radius, what do you think will happen to the volume? A lot of time, I'd like you to put down your own guess. Put down your own guess. It's a hypothesis. A lot of people would say it should double the volume, and that makes sense. But let's check it to make sure. It says find the new volume in terms of pi to check to see if your prediction is correct. So if the radius now is doubled, that means the radius is going to be 6. So in the cylinder, we're going to do pi times radius squared times the height. So it's pi times, oh, I meant to say 12. Radius should be 12 now. Sorry, excuse me. So 12 squared, which is, I know that's 144, times the height is still 6. So 144 times 6, I'm going to get some sort of big number, I'm pretty sure. 864. So we get 864 pi. So how many times bigger is that than the original? We want to see if it's 2 times bigger, like my guess would have been. So I'm going to take that to 864 pi and compare it in a fraction to the original, which is 216 pi. And I know that the pi's cancel out, and I'm going to actually take a guess and say that they can both be divided by 216, because 864 is a lot bigger, so it might go in there. 864 divided by 216 is a nice even 4, which is great, because 216 divided by 216 is just 1. So 4 over 1, meaning it's 4 times larger. So you got to take that. That's interesting, isn't it? It's 4 times larger. So let's maybe use that guess and try number 6. Suppose you double the radius and the height of the cylinder. So now the radius is 12. So before we had the radius was 12 and the height was still 6. Now we're going to say the radius is 12, and we're going to say the height is also 12. We're doubling that as well. What do you think is going to happen? How many times bigger do you think it'll be? 6, 8, 10, 16? I don't know. Make a guess. And now we're going to find it. So find the new volume in terms of pi to check our prediction. So whatever your prediction was, we'll see if it's right. So volume of this cylinder now, pi r squared times height. The radius is 12, so 12 squared, times the height of 12. So really we're doing 12 times 12 and then times 12 again. So 12 times 12 times 12 is going to be an even bigger number. 1,728 pi feet cubed. So if I want to see how many times that is bigger than the original, I'm going to take that 1,728 pi over 216 pi and cancel out the pi's. I'm going to guess that we can divide them both by 216 again. Because 216 divided by 216 is 1. That divided by 216 gets me 8. So if your guess was 8 over 1. So if your guess was 8 times bigger, you were right. So we're just playing around with how it does impact if you change one little part of like the radius or the height, how it impacts the whole volume. it tends to be a lot more of an impact with volume than it would be with area or just regular distances. So last question. The volume of a cylinder is 8 pi centimeters cubed. The radius and the height are the same. So think about a cylinder. Pi times radius squared times height. But the radius and the height are all the same. So it's like we're taking pi times radius times height. But all of those have to be the same number. And it should end up equaling 8 pi. So the radius times the height has to equal 8, essentially. What's the radius of the cylinder then? What's the only number when you multiply it by itself 3 times gets you to 8? Well, 1 times 1 times 1, that's 1. 2 times 2 times 2. Oh, that's 8. So that means your radius is 2. And this would be centimeters. So explain that. Make sure you explain that. And then that's it for this lesson. So I would say those middle 3 were probably the most challenging of them all. But this is Day 2 of Lesson 26, page 263 and 264. Hope that answers any questions you might have had, or you were able to check your answers as well. See you next time.